we did, right? So in the first case, we saw that we had the air in between those plates. So this was the first case, and then we learned that we have some dielectric slab in between these parallel plate capacitors. So then we calculated the capacitance, and then we had this two plates, but they were tilted. This was the first plate, and the other one was tilted with some angle theta. Right? Then we calculated the capacitance. So now let us talk about the other cases as well. So the next case, this you have already done in the CPC course, but Madhya is here, so let me do that again. Okay. So now we have the capacitance of a parallel plate capacitor um, which is partially filled with dielectric. So what do I mean by that? So we have two plates, and in between these two plates, right? So let's say this is a positive one, and this is a negative one. So some slab is here, but it is partially filled. So we have some slab with some thickness, and it is partially filled. Okay, so do I have another Okay, so this is partially filled. Yeah, now it is. Right, and it has a the thickness of T, right? And it has a dielectric constant K. So we have two plates. These are the two plates. And in between these two plates, this is partially filled with some dielectric slab, right? So this thickness is T, and then this is okay, and the total distance is D, right? So then again, we'll have to calculate the capacitance for this one. And the capacitance would be what? This would be Q by V, right? So ultimately, we'll have to calculate this voltage between these two plates, right? So the voltage will have two contributions. So voltage would be of air, and then the voltage of dielectric, potential of dielectric. Okay, so this is, we already know that the potential is E into T, right? So then we'll have this air, which is E air, and D air. And then this V dielectric would be E dielectric, and then D dielectric. Okay, so what is the electric field of the parallel plate capacitor? What is the electric field of the sheets? We have derived this. So what is the electric field?
7 by
Yeah, sigma by epsilon naught, right? And what is this distance here? How much is this distance? So we have
8
yeah, total is D, and this one is T. So what is left? What is left?
DMNST.
D minus T. So this is D minus, right? And what is E dielectric? What is the electric field due to dielectric? Yes. What is the electric field due to dielectric? That is simply sigma by E, right?
Yes, ma'am. Sir.
So this is sigma by epsilon, which is epsilon naught into K. And what is the distance of dielectric? T. Is this clear, guys?
Sir.
Is this so? When we simplify this, right? So sigma by epsilon naught is common. So sigma by epsilon naught is common, and this is T minus T plus T by K. Okay. So now we have calculated the potential. We have calculated the potential, so we just plug in this value in here. So C would be Q by this potential V. So this is Q by sigma by epsilon naught and D minus T plus T by K. So this we can write this Q or this sigma in form of Q. So this epsilon naught goes in the numerator, and then the sigma is Q by A, and then this is D minus T plus T by K. So this Q cancels, and what do we have? We have C, which is A E epsilon naught divided by T minus T plus T by K. So this is the capacitance of a capacitor which is partially filled with the dielectric. Right? Is this clear, guys? So this you have already done in your CBSE class, but
Yes, sir.
I'm just repeating that. Okay. Is this clear, guys?
Yes, sir.
Okay. Tarif and Madia, clear, or do you guys have any questions?
Yes, sir, clear.
Okay, so please note it down, guys. Please note it down, and then we'll do the next part. Whenever you guys want me to scroll down the screen, you guys, this is dielectric. By epsilon. Whenever you guys want me to scroll down the screen, you guys,
Sir, can you explain the diagrams? Sir, can you explain the diagram?
oh, diagram. Okay.
Yes, sir.
Yeah. So we have these two plates, right? So what do we have? We have these. So what do we have? Let's say I don't have this the one part. So we have these two plates, and in these two plates we have some dielectric which is placed like this, right. So this will have some thickness, right? This will have some thickness, and there would be two kinds of electric field. So now those two kinds of electric field will contribute to the potential in a different way. So the total potential difference between these two plates would be due to this dielectric and then this air, which is between these two plates. So is this clear, Tarif?
Yes, sir, clear.
Okay, so where should I put the screen? In here.
Sir, can you scroll a bit up?
Yeah, whenever you guys have completed, tell. I noted everybody. Everyone completed.
I'm ready.
Okay, so now the next thing is
Sir,
that.
I'm writing, sir.
Oh, you are right. Oh, sorry, sorry. Yeah, so
Sir, here electric field.
yeah, yes, yes.
No, sir, nothing.
So whenever everyone has noted these steps, completed everyone.
Yes.
Okay, Chavez and Tari, what about you guys?
Yes, sir.
Yes, sir.
Noted. Okay, so now,
Yes, sir.
okay, so the next thing is that in place of the dielectric, we have a conductor which is placed in between, which is partially filled, right? So we have some conductor, right? So what is the electric field inside the conductor? What is the electric field inside the conductor? Yeah, do you guys remember? We have this conductor, or let's say we have this conductor. So what is the electric field inside the conductor? Do we have any charges in?
Zero.
So this is zero, right? So this is zero. Okay, keeping this in mind, then we have, right, then we have this, what is the voltage or potential? So this would be voltage due to conductor, and then this is due to air. So this is again E into E conductor and D conductor, and then E air, and then D air, right? So then E conductor, we know that inside is zero, so this is cancelled. And then E air is
Sir,
what?
this is for conductor.
Yeah, this is for conductor. So now we are calculating the capacitance. Capacitance partially filled with conductor. Right, this is of thickness G. Okay. So now, similarly, following the same process, this would be what? Sigma by epsilon naught, and this is G minus, right? So then the potential is sigma by epsilon naught, D minus T. Then capacitance is what? Q by V. So this is Q by sigma by epsilon naught, D minus T. So then this epsilon naught goes in the numerator, and then again sigma is Q by A. So G minus T, then Q cancels, and we have A epsilon naught D minus. So this is the capacitance of a partially filled parallel plate capacitor with the conductor. Right. So you guys quickly note it down, and then we'll do the other kinds of capacitor. So this much is all we need to know about the parallel plate capacitor. Right. Yeah, whenever you guys want me to scroll down the screen, guys,
So can you please go down?
Can you scroll a bit up?
oh, up to this point, okay, is it okay?
Yes, sir. Yeah, whenever you guys have completed, please tell.
That's
Done. Sarif and Shavez, what about you guys?
Yes, sir. Done.
Shavez, done.
Yes, sir. Done.
Okay. Now let me see you guys remember or not. So the next topic is spherical plate capacitor. So we have two spheres, right? In the case of the parallel plate, you have two sheets. Now we have two spheres, right? Hollow spheres. And this one has charge plus Q. And this is earth, right? So this has an earthing. So if this has an earthing, so what charge it will acquire?
0.
This is earthing, right? So it will acquire minus
Minus, yes, sir. Minus.
minus Q charge, right? So this has minus Q, this has plus Q. Now let's say that this is R1 and this is R2. So we have to calculate the potential difference between this and this sphere, right? So the potential is potential difference between R1, which is 1, and minus 2. So now you guys tell me that if I want to calculate V1, right? So at this point, at this surface, I want to calculate the potential. So this we have done it. This question we have done it. So you guys tell me, at this point, how many contribution would be there? Yeah. How many contribution would be there at this point?
Sir, with okay.
Yeah. Chavez, what did you say? At this point, we are
KQ,
calculating. Yeah.
KQ by R1
R1 then
plus K into minus Q by R2.
R R yes,
R2 is
R1 or R2. Yeah. What did you say? Did you say R2 or R1?
R2.
R2, right? Absolutely right. Good. So at this point, this is V surface, right? For the smaller radius one. This is surface and this one is V inside for the bigger. So we have two contributions, 1 and 2, right? So the surface one is how much? This is KQ by R, which is R1. And this is inside. So what is the potential at this? So this radius is R2 and we are calculating the potential inside of the hollow sphere. So we already know that that is KQ by radius, right? So this is as Chavez said, so this is KQ by R. Is this clear, guys? So good, good, Chavez. This is KQ by R1 and minus KQ by R. So in today's class, we'll not bother Madhya with the questions, right? Because she is coming after a long time, so she may be not familiar with these topic. But yes, Sari, second question for you. So now we are calculating
Sir,
the potential at this point. So what would be the
sir.
potential? Yeah, what would be the potential?
A minus Q by R1.
K minus Q by R. Why minus Q?
Yeah, because it's traveling from negative. Oh no, sir, it's positive. Yes, sir.
So first would be from this contribution,
Yes, sir.
right? So first is what? First is V outside, right? And
Yes,
the
sir.
other one is V surface, right? So this is a small one, and this is a bigger surface or bigger sphere. Now you tell
The KQ by R minus K
which are R1 or R2?
R1
R1. So we are calculating outside
minus R2
R2, right? And then
plus K minus Q by R1.
R
R1.
we are calculating at the surface
Oh, yes, R2.
R2. So this is KQ by R2 and KQ by R2. So that is the meaning of the earthing. That potential at this surface becomes zero, right? That is the meaning of the earthing, right, guys?
Yes, sir.
Okay.
Sir,
So Yeah. So now let us calculate what is the potential difference. So potential difference is V1 minus V2, which is KQ by R1 minus KQ by R2 and minus of 0. So this is what? KQ by R1 minus KQ by R2. So this is the potential, right? Now we have calculated the potential and we know the charges. So the charges are what? This is Q, right? So the capacitance would be what? Q by V, which is Q by V, right? V is KQ by R1 minus KQ by R2. So we take K and Q outside. So this is 1 by R1 minus 1 by R2. So
and Q
QQ
cancel.
can, and then we have 4 pi epsilon naught, and then this is R1 R2, and this is R2 minus R1. So what we'll get? So C is 4 pi epsilon naught R1 R2 divided by R2 minus R. So this is the capacitance of a spherical capacitor. Any doubt in this, guys?
No, sir.
Okay, so please note it down. So this is a spherical capacitor. So we have parallel plate capacitor, then we have spherical plate capacitor, and then we have cylindrical. So the last one will do the cylindrical. And yeah, whenever you guys want me to scroll down the screen, you guys tell. Yeah, should I scroll down? So whenever you guys have noted it down, please tell. Yes, noted everyone.
Yes, sir.
Okay, Tarif and Madhya, what about you guys?
Answer.
Okay, so the next topic is uh, cylindrical capacity. Okay, so this is the cylindrical capacitor that we have, and then the outer surface. This is right. And then what do we have? So the radius of this one is R1, and then radius of this one is R2, right? So we have to find out to calculate the capacitance, we have to find out what is the voltage difference between these two plates. So what is the voltage at this point and what is the voltage at this point? So this is a continuous distribution. So what do we know about the electric field? Right. So electric field for this cylinder is lambda by 2 pi epsilon naught r. This is the electric field. Right, guys? Now, how can we calculate the potential from the electric field? Do you guys, yeah, do you guys remember? So we have to calculate the potential difference between 1 and 2. So do you guys remember how do we calculate the potential difference from the electric field? Yeah, anyone remember? Yes, anyone remembers what is the, from how can we get the potential difference from the electric field? We did so many questions, guys, right?
So
So
E is equal to QE, that formula.
P is equal to QE.
Yeah.
Huh? V is QE. F is QE, right? What is,
Oh, sorry.
yeah, yeah. So, okay. So we have, let me again. So you guys revise, right? So work done in bringing a charge from initial point to final point was what? This was minus Q E dot dr, right? From initial to final. And then this was Q V final minus V initial. So Q got cancelled and potential difference was minus of initial to final E dot dr. This was the potential difference, right? Now do you guys remember? Yes, guys. Yeah, do you guys remember now?
Yes.
Okay, so we have to find out V1 to 2. So this would be what? This would be minus of EDR, and R is in the same direction as the electric field. So both are parallel, right? And then this is final. So this is 1 and then this is 2. So this is the potential difference, right? So we know that electric field is 1 to 2. This is lambda by 2 pi epsilon r, and this is dr. So lambda by 2 pi epsilon naught, and minus is taken outside, and we have 2 to 1 by r dr. So what is this integral? What is this integral, guys? This we have, yeah, this integral we have done in the few 2 or 3 questions before. So what is this integral, guys? Yes, Chavez, Tarif, and Maria. What is integral of 1 by x dx? What is this integral? Hmm. So this we did a few questions before, right? What is this integral, guys? Yeah, so anybody writing out? No one is writing in the chat box. Okay, so let's go in the flashback. Let's go few questions before. What is this integral, guys? Yes. Uh, so we were doing this question, right? We were doing this question, and then we came across this integral, 1 by x integral. So this is log x, right? Now do you guys remember? Yes. Understood, guys? Okay, so this would be how much? Then this would be minus lambda by 2 pi epsilon naught, and this is log, or you can write it as log of r, and the limit is r1, right, to r2. This is r1 and r2, right? This is r1 and r2. Then what would be the value? So how do we solve this integral? First we put what value? The upper limit. So log r1, and then subtracted by the lower limit, log of r2. So do you guys remember the property of log? Log a minus log b. What is this?
Log A by B.
Absolutely right. So this is log a by b. Good. So this is minus of lambda 2 pi epsilon naught, and this is log of r1 by r2. Clear? Now, if I take this minus sign inside the log, so what would be that? If I take the minus sign inside the log, so what would be that? Okay, let me ask this question. So if I have log x to the power 5, so what is this value? What do we do with this 5? What is, where does this power go? You guys have came across this log before, right? You guys know the properties of log, right? So this power goes in the multiplication. So this is 5 log x, right? That is why log of 1000, this is what? This is log of 10 to the power 3. So 3 comes here, and this is log 10 to the base 10. So this is 1. So this is 3 into 1. This is, so that is how we solve the logs, right? Similarly, this 5, if I do the back calculation, so this 5 will go in the power. So similarly, this minus will go in the power. Okay. So then it will be reversed, and you will get lambda by 2 pi epsilon naught log of R2 by R. So this is the potential difference, right? Then we want to calculate, ultimately we wanted to calculate the capacitance. So this was Q by V. So then what you will get? This will be Q by lambda by 2 pi epsilon naught and log of R2 by R. But this lambda, right? This lambda is, so this much length is, how much? This is L, right? So you have this linear charge density. Okay, you have this linear charge density. So what is the linear charge density lambda? Can you guys tell me? Yeah, can you guys tell me what is this linear
Q by
charge?
L.
So this is Q by L. Absolutely correct. This is Q by L. So we'll put the value of this Q by L and then we'll put the value of Q by L. So this is Q and this is 2 pi epsilon naught and this is Q by L and then log of R2 by R. So this Q cancels and C is what? 2 pi epsilon naught L divided by log of R2 by R. So this is the capacitance of a cylindrical capacitor. Any doubt in this part, guys? Do you guys have any questions?
No, sir.
Okay, so please note it down. So please note it down. And whenever you guys want me to scroll down the screen, guys, yes, whenever you guys want me to scroll down the screen, you guys tell me, right? So
Yes, sir.
Is this
May I
okay?
scroll a little bit?
Up or down?
Yes, sir.
Yes. Whenever you guys want me to scroll down the screen, guys, that noted up to this point. Yes, everyone noted.
Sir, I'm doing, sir. Okay.
Written. Okay, so the
Yes, sir.
last part is When everyone is noted, please tell. Right. Completed everyone? Yes, everyone completed.
Yes.
Okay. Tarif and Shaved, what about you guys?
Yes, sir.
Okay, so yeah, we'll stop at here, right? Only for today's class, we'll stop at here and we'll continue from the next class. Okay, guys. Yes.
Yes, sir.
Bye, guys. Allah Hafiz. Allah Hafiz, guys. Bye.
All right.
Enough.
Walaikum salam. Walaikum salam.
Thank you, sir.
Yeah, Allah Hafiz. Allah Hafiz.
Hello. Good evening,
Yes,
sir.
yes. Hello, Aisha. Assalamu alaikum. Assalamu alaikum.
Welcome, sir. How are you, sir?
I'm good. How are you? How are you?
I'm good, sir. Sorry, sir. I joined in the wrong meeting.
Oh, no worries, no worries, no worries. Okay. So yeah, and sorry about the timing, about the yesterday's, right? So
No problem, sir.
there were so many mix-ups, right? So yeah.
Yeah, yes, sir.
Okay. So what we were doing in the previous class?
So we were learning about polynomials.
Yeah. So we understood about the graphical representation of the zeros of the polynomial, right?
Yes, sir.
Now let us talk about the solutions of the polynomial, right? So yeah. So we understood about the graphical representation. Now let us talk about the roots or zeros of the polynomial, right?
Okay, sir.
Yeah. So let us take the quadratic equation, right? So what is the degree of this quadratic equation?
Two, sir.
Degree is 2, right?
Yes,
Degree
sir.
is 2, which means that how many zeros would be there?
Two zeros.
So number of zeros are 2, right? And so there is a general form of the quadratic equation, right? So
Yes, sir.
general form of a quadratic equation. So this is represented by what? Ax square plus bx plus c equals to 0. So this is the general form of a quadratic equation. And in
Yes,
this, in this equation, we have these a, b, c, which are real numbers, and they are called the coefficients, right? They are the coefficients and constants. So c is the constant term, and a and b are the coefficient. So a is coefficient of x square, b is coefficient of x, and c is the constant, right?
okay, sir.
So this is the general representation of a quadratic equation. Now, if we write the quadratic equation in the form of 0, so in the form of 0, so we represent the quadratic equation like if let's say alpha and beta are the 0, so this is how we represent the quadratic equation, right? So
Yes, sir.
this this is in the form of coefficients, and this is in the form of zeros, right?
Yes, sir.
These both these equation are same quadratic equation, which means that they are equal, right?
Yes, sir.
So if we compare these equations, right? So we have ax square plus bx plus c equals to 0. But in this equation, what is the coefficient of x square?
One.
1. So we have to make the coefficient of x square 1 in here to compare these two, right?
Yes, sir.
So how can I make the coefficient of a x square as 1?
So we can just write x square
Yeah.
or put the value of a as one.
No. So if we put the value of a, we don't know what is the value of a here. This is a general. So this a can be anything. This is a real number, right?
Okay, sir.
So to get the coefficient 1, let me divide this by a, right? Then what
Yes,
will
sir.
I get?
X square.
So then this will be divided and I'll get 1. So if I'm doing this division in this term, so then I'll have to equally divide all these terms, right?
Yes, sir.
So let us divide this by A, let us divide this by A, and it is this one. So if we are doing the equal division, then it is okay, right? But
Yes, sir.
if you only divided this one by A, then it would be wrong, right? But we are dividing equally, so this doesn't make any change, right?
Yes, sir.
So this is one, and now this is B by A, and then this is C by A, and this is equal to 0, right? So now we
Yes, sir.
can compare these two terms, all right?
Okay, sir.
So if these two equations are equal, then all the coefficients would be equal, right? So which means
Yes, sir.
that, yeah, which means that coefficient of x should be equal, right? Which means that this b by a, this is equal to what? Yeah, by this,
Alpha plus beta.
so minus alpha plus beta, right? This
Oh,
is the
yes, sir.
coefficient. So this is the coefficient. So if I take the negative sign in this side, so this is alpha plus beta is equals to minus b by, right? And similarly, if I compare these constants, so if I compare the constant, what will I get? Comparing the constants. So I will get alpha into beta as b by. Is this clear?
Yes, sir.
So what does this tell us? That if we have a quadratic equation, right? If we have a quadratic equation which is given like this, and it has two roots which are alpha and beta. So I can write the sum of the zeros as minus b by a, and I can write product of the zeros as c by a. So this gives me the relationship between the zeros and the coefficients. Is this clear?
Yes, sir. Yes, sir.
Okay, so that is how you get the relationship between the zeros and the coefficients. So the sum of the zeros for a quadratic equation, this is minus b by a, and product of the zeros is c by. Okay,
Okay, sir.
so please note it down, and then we'll do the next part. So
Yes,
please,
sir.
yeah, note down from it. So the second exercise of this polynomial is all about the relationship between the coefficients and the z. So we'll do so many questions based on that, and then we'll understand these properties.
Okay, sir.
Whenever you want me to scroll down the screen, please tell.
Sir, I've noted it down.
Oh, you have noted it down. Good. So this one is also completed.
Yes, sir.
Good. So similarly, this is not part of the syllabus, but similarly, for a cubic equation, right? Cubic equation. So the general form of the cubic equation would be what? This would be ax cube plus bx square plus cx plus d equals to 0, right?
Yes, sir.
So similarly, the sum of the zeros, how many zeros would be there?
3 zeros.
3 0, absolutely right. So we have alpha, beta, and gamma. These are the three. So this would be alpha plus beta plus gamma, and the sum would be simply minus b by, right?
Yes, sir.
And then second is that sum of the products of two zeros taken at a time. So alpha plus beta plus beta into gamma plus alpha into gamma. So this is what is the coefficient after B? So this is C. So this would be C by, right? And if I
Yes, sir.
ask you what is alpha beta into gamma, this would be what? So this would be D by A. And what would be the sign? Positive or negative?
Mm. So
So
positive?
so see here, this one was negative, right? And then
Yes,
it
sir.
was positive. So we have alternate signs. So this would be negative, right?
Oh, okay, sir.
Yeah. So these are the relationship between the zeros and coefficients for the case of the cubic equation. Understood?
Yes, sir.
Yeah. Please note it down.
Yes, sir. Done.
Done. So if I ask you to derive this, so how will you derive this? So I will give you a hint that there would be three factors. If I have a cubic equation, then I would have three factors. So you multiply these three, and then you will get some cubic equation. Then compare this with it. So then you will get all these three. So what you do, you try it at your home, and then you will see how do you get these relations. Understood?
Okay, sir. Yes, sir.
Following the same process that we did in here. So
Okay,
following the
sir.
same process. Okay, so now let us do some questions to understand these concepts. So here are questions. Okay, the first exercise is the toughest one. So in the whole 10th class, in the whole chapters that you have, how many chapters? You have 14 chapters, right?
Yes,
So
sir.
this exercise is the toughest one, right? And
No,
and
sir.
I am I'm saying it oppositely, right? So this is the easiest one. I don't know what is the purpose of this exercise, right?
Yes, sir.
In this exercise, they want us to calculate the number of the zeros, and the graph of the px are given, right?
Yes, sir.
So for this case, how many zeros would be there,
Zero, sir.
right? Because it is not intersecting this x-axis, right?
Yes,
And
sir.
for this one, how many zeros?
One.
One. And for this one,
Three, sir.
three. Good. So you already know the answer. Then one, two, three,
Yes, sir.
four,
Four.
and one, two, three. So these are the right. So yeah, this was the very toughest exercise, right?
No.
N-
Yes, sir.
Okay, now let us come to the second exercise, right? Okay, so this was from the previous batches. Okay, so what do we already know? We know that we have a quadratic equation, and this is the quadratic equation, and we know that the sum of the zeros is minus b by a, and product of the zeros is c by a.
Yes,
These
sir.
three things, right?
Yes, sir.
Okay, so now let us solve some question. But before that, do you know the how to solve the quadratic equation?
Yes, sir.
Okay, how many methods do you have? So to solve the quadratic equation.
Sir, like, uh,
In this chapter, we will only use the first method. But when we'll do the quadratic equation, then you'll get to know about the other method, right? So one method that you already know is this middle term splitting method, right?
yes, sir.
Middle term splitting, and then the other one is what? Quadratic formula. we will discuss this one in the quadratic equation chapter. But this one we'll use in this chapter, right? So are you
Yes, sir.
familiar with this middle term splitting method?
Yes, sir.
Good, good, good. So what do we mean by, let's say that we have this x squared minus 2x minus 8 equals to 0. So the middle term splitting, as the wording suggests, we have to split this term. This is the middle term, and we have to split this term. But there are certain rules that we have to follow, right? So
Yes,
first,
sir.
yeah, first rule is that we have to factorize a into c, right?
Yes,
And
sir.
then and then we add or subtract the factors in such a way that we get the b. This is these are the two rules that we follow, right?
Yes, sir.
Okay, so what is a into c in this case?
Sir, it's -8.
Minus it. So take only the positive side. So now take only the positive. So we have to factorize this 8. So the factors of 8 would be what? This would be 2 into 2 into 2. Right.
Yes, sir.
Now we'll have to get two factors. So one combination would be 2 into 4. Right. The other
Yes, sir.
combination would be 1 into 8.
8.
Right. So these are the two combinations. Right.
Yes, sir.
So which combination will give me minus 2?
Sir, 2 and 4.
2 and 4, right? So 2 and 4 we'll choose. And what would be the sign of 2 and 4?
So since we want -2, so we'll put the sign for 4 as minus and 2
Yes,
as plus.
absolutely right. So this is plus 2 and this is minus 4. Good. So these are the two factors, plus 2 and minus 4. So we have x square minus 4x and plus 2x, right? Minus 8. This is equal to 0, right?
Yes,
And
sir.
then this is what? This is x minus 4 and this is 2x
Plus.
minus. So this is again common and then we have x plus 2.
Yes, sir.
So, so we'll have x equals to 4 and x equals to minus 2. So alpha is equal to 4 and beta is minus 2, right?
Yes, sir.
So yeah, so in these set of questions, they are asking that we calculate alpha and beta first and then prove the relationship between the zeros and the coefficients, right? So we
Yes,
have
sir.
this, yeah, so we have this quadratic equation, right? X square minus 2x minus 8 equals to 0. So what is A, B, C?
Sir, A is 1,
Yes.
B is -2, and C is -8.
A is 1, B is minus 2, and C is minus 2, right? And
Yes,
we know what is, we have just calculated alpha is 4 and beta is minus 2. So first, we need to calculate what is the sum of the zero, right? So
yes, sir.
sum of 0, which is alpha plus beta, which is 4 minus 2.
Minus B by. Yes, sir.
No, we have to prove that relation, right? So we cannot
Yes,
use
sir.
this is 2, right? Now,
Yes, sir.
what is this quantity minus b by? So minus b by a is minus of minus 2 and divided by 1. So this is 2. So we can clearly say that from 1 and 2, we can say that alpha plus beta is minus b by. So we have
Yes,
proven, yeah, we have proven that sum of the zeros is minus b by, right?
yes, sir.
Simi yeah. Similarly, we calculate what is product of zeros. This is alpha into beta, which is 4 into minus 2. So this is minus. right? Now, what is
Yes, sir.
C by A? C by A is minus 8.
Minus 8 by 1.
So this is minus 8 again. So this is equation third, and this is fourth. So from third and fourth, we can say that alpha into beta is C by, right?
Yes, sir.
So this was about the first question, right?
Yes, sir.
So you have already done in your school, right? These questions you have already done. So yeah, do you want to note down this part because you already know? So it is not.
Sir, I already noted it down.
Oh, you already noted it down. Good. So
Yes, sir. I noted down when you explained.
oh, so you were simultaneously understanding and then noting it down. Oh, okay.
Yes, sir.
So in my class, there is one, right? So what I follow is that first question I do and the rest of the questions my students, right? So this
Yes,
is
sir.
what we'll follow. So first question I did, and then you will do the second question, right?
Okay, sir.
So yeah, so first, right? Let me erase this part, and okay, so you will tell me all the steps, right? That we have
Yes, sir.
noted. Okay, so this is all about this chapter, right? We have done all the concepts, so we just have to solve these questions, right? And we'll do
Yes, sir.
other questions as well. So okay, the yeah, so this is the question. So 4s square minus 4s plus 1 equals to 0, right?
Yes, sir.
So A, what is A?
Sir, A is 4,
And B,
B is minus 4,
and
C is 1.
okay, and tell me what is alpha and beta. Find out and tell.
Okay, sir. Sir, both of them, both alpha and beta are 1 by 2.
1 by 2. Okay. So your answer is 1 by 2. How can we check whether this is correct or not?
So then next you have to follow by the equation.
Okay, so yeah, this is the equation, right? So I want to check whether these are zeros or not. So if I put the value of alpha in this one, what will I get?
Sir, you'll get 0.
0, right? So this is how we'll check. So this is 4 and half square and minus 4 and half and then plus 1. So this is what? This is 4 and then this is 1 by 4, right? And then this is 4 by 2 and then plus 1. So this is 2, this is 1. So 1 minus 2 plus 1. So 1 plus 1 is 2 minus 2 is 2, which means that our answer is correct, right?
Yes, sir.
Okay, so Yeah, which method did you use? The middle term splitting.
Yes, sir.
Yeah, and we can also use the other method as well. So we have this 4s square. So this is 2s whole square, right? This is
Yes, sir.
minus 4s. So this is minus 2 into 2s into 1. And then this is 1 square. So what is this identity? Can you identify?
So this is the first, no, second one.
Second one, yeah.
Sir, the
So this is,
A
yeah,
A minus B the whole square.
yeah. So this is a minus b whole square, right?
Yes, sir.
So we have 2s minus 1 whole square. This is 0. So we have 2s minus 1, 2s minus. So we'll get s equals to 1, right? S equals to 1. So this is also, this is another way we can solve this problem, but only these kind of problems. So this is limited to only this identity, right?
Yes, sir.
Okay, good, good. So now we know the solution. Then we can, yeah, then we can do what? Then we can prove the relationship between the zeros and the coefficient. So what is sum of zeros?
Sir, it's 1.
Half plus half, right? So half plus half is 1. Okay. And yeah, so what is minus b by a? Minus b by a is minus of minus 4.
Minus 4 by 4.
So this minus cancel, this 4 cancels, this is 1. So we can say that alpha plus beta is minus b by. So this is the whole crux of the this exercise, right? And then
Yes,
what
sir.
is the product? Product is 1 by 2, 1 by 2. So 1 by 4.
By 4.
And what is c by a?
It's 1 by 4, sir.
1 by 4 again. So which means that product is c by, right?
Yes, sir.
So this is all about this first question, right? You solve all these other ones. So let me check whether I have yeah, this which one is the assignment? Do I have, yes, this one. So I have okay. So let us do some different kinds of questions, right?
Yes, sir.
So so this you already know, right? The when we have the zeros, then how can we write the quadratic equation, right?
Yes, sir.
So yeah, so we have these zeros, right? So alpha is 3 and beta is minus. So please tell me what is the quadratic equation.
Okay, sir.
Yes, what did you get?
Sir, x square
Yes,
plus x plus 12.
plus
No, sir,
12.
minus 12. Minus 12.
Yes, yes, absolutely correct. Right. So we use this relation, right? X square minus alpha plus beta x, and then alpha into beta. Good. So yeah, this is the correct answer. Now let us do one more problem and then yeah, then we'll end this class. Good. Okay, so this question, third one, right?
Okay, sir.
If alpha and beta are the zeros of the polynomial, so we have this equation, right? Quadratic equation, and the roots are alpha and beta. Okay,
Yes, sir.
so then we'll have to find out the value of alpha plus beta plus alpha into beta. So how will you find out the value?
So we can use that alpha plus beta is minus b by a, and then
Absolutely
we'll
right.
use alpha into beta is c by a.
Yes,
So then we can find the values of both alpha plus beta and alpha into beta, and then I'll add all of them.
absolutely right. Absolutely right. Good. So this is minus 7 by 2, right? And this
Yes,
is
sir.
5 by 2. So then we can just add these two, right? Alpha plus beta plus alpha into beta. This is minus 7 by 2 plus 5 by 2. So this is minus 7 plus 5 by 2, which is minus 2 by 2. So which is minus, right? Good.
Yes, sir.
Okay, so I will give you one homework and then we'll end the class, right? So